thought today we'd just write a trivial program to highlight how to import, external functions from modules like your own library. Basically, how to just compose programs in Fortran. So we're going to use a trivial example from one of these books that I did not have a great relationship with, Flow and Open Channels. So we're just going to do a simple function that basically lets us calculate the flow using Manning's equation. Essentially like made up of the area, hydraulic radius, and the slope of a channel. You can Google some more into that if you really want to, but let's get stuck into it. I've pre-written some code this time, so you don't really have to watch me type everything out, but this is essentially here the function. So I've declared a function called Manning's. It takes in some parameters, so the area, hydraulic radius, the slope, and this Manning's coefficient. They're the inputs, and then it returns Q, which is the flow. Here's the equation. In terms of syntax, function keyword, pretty straightforward. Name of the function, parameters, it's pretty much what you'd expect to see in basically most languages. The thing that's maybe a little bit unique is you declare the result right here. So we're saying the result of this is Q. So we have to define our inputs as well as our output. And then there's no return keyword or anything. It's basically when this code block executes, whatever the value of Q is at the end is what gets passed back. In terms of the syntax for declaring a module, we use the module keyword. So I've just called this module nerd stuff. This contains keyword is important, so it contains this function, and then you just end the module. Now there are other types of functions in Fortran called subroutines. So the function keyword is something that takes some input and returns a value. So anytime you're returning a value, you use function. There are also subroutines which are more or less identical, except they don't return anything. So they either do something, I don't know, like reading or writing to a file, or potentially just like actually mutating the values passed in. So yeah, if you're more familiar with like a functional style programming, functions definitely, subroutines are the other construct that we have available to us. We might see them at some stage. They're kind of useful for just composing your program. But anyway, so we have this module. Let's look into the file tree here. So we've just got a flat thing here. This might be in like a library directory, whatever. It doesn't really matter. It's just an external file. Let's go into our main program here. So program is called example function. In order to use the module, we use this use keyword. So we're using this module. This module only has a single function, so we could just do that. If we have multiple and we only want to import a specific function, we use this only keyword, and we just list the names of the functions that we want. So we only want the Manning's function. And this kind of has to go at the top, and then we just do our normal implicit none, variable declaration. These are the inputs, so we're just going to assume for the sake of this program that it's doing standard rectangular flow, so just a normal rectangle, two sides, a bottom, and then another side. That's what the channel looks like. It's literally a rectangle, just to make calculating the area and hydraulic radius nice and easy. Inputs here, I'll just stub them out for now. So we got a width of 8, height of 1 in meters, slope of 0.01, and this n is just a Manning's coefficient. You get this experimentally, basically. You basically measure your flow, all your dimensions, and then you calculate n based on what you see. This is almost like a friction coefficient. Like the shape and roughness of the channel will determine how freely water flows through it. To get into the formula, so this is our function here. We just call it like this. Q equals Manning's, and we pass in the variables there. It's a little bit annoying we don't have named variables or anything in Fortran to my knowledge. Modern Fortran has object or struct type syntaxes, so you could I guess pass in an object into that has these properties if you really wanted to get around ordering and stuff. But typically in a Fortran program you'd see it defined like this. So this is just some intermediate quick maths to calculate the area. Area of a rectangle is, the width times the height, where y is the height, or depth of water in this case. Perimeter, the wetted perimeter is, the width, so the bottom of the channel, and 2 times the edges. So, and the hydraulic radius is the area divided by the wetted perimeter. So yeah, that's why we chose a rectangular channel. Obviously in real life channels can be all kinds of crazy shapes, and even just, calculating the area, you typically would take the integral of some function. And then we're just going to write the flow there. So that's pretty much the syntax for, using a library. If you're using a proper Fortran IDE, this should just compile and work. If you're not using a proper Fortran IDE and you're just using a text editor like I am, if you go to build this, like we normally would, we're going to get an error saying we can't find the module. So we actually need to compile the module and link them separately. So we actually need to do compile and then compile the program like that. So we compile the library like that, and then this is how we basically compile it. So we give it the main F90 file, then we link it to nerdstuff.o, which is kind of the object that was built from compiling the nerdstuff file, and then we want to call that executable main, so we run that, and then we can simply execute main like normal. So yeah, that's, I guess, the simple part of it. We might expand on this a little bit. So obviously doing this kind of stuff gets a little bit tricky in non-trivial systems, with lots of dependencies everywhere. So we'll actually walk over setting up the Meson, whatever build system. This is something that I've never used because I always used a Fortran compiler, so I had to do some playing around with this, but we need a meson.build file. Meson.build. And then we're going to configure it. So project execute, yeah, cool. So this is what I want to call my project using functions. It's a Fortran project, I guess pinning the version, and the executable we're going to produce is called example function, and the files it depends on are main and this. And then we should be able to just run meson setup build. Cool. And that will generate a bunch of stuff for us in our IDE. So if this would basically generate a build directory with a bunch of stuff in it, and then to actually build the executable, I think it's Ninja C build. There we go. And then it'll build the executable in build. Example function is what we named it, so we should be able to run example function. Yeah, cool. So that's basically how you use this tool. Pretty simple. I would recommend doing this rather than manually trying to compile your dependencies and linking them. Seems pretty straightforward. We'll see how this goes as this grows in complexity, but it looks promising. So that was the next thing. Building kind of changes a little bit when you're using dependencies. What else? Okay, let's do file IO in this. So let's create a text file. I'm just going to call it input.txt, and we're just going to read a bunch of these values from a text file basically. So let's just put something in this text file. So what are we reading in? We want the width, the height, the slope, and manning. So I'm just going to do this temporarily. So this is just some fake widths and heights, and let's just paste in the same value for the slope, or whatever. We can change it up, it doesn't really matter. 0.19, 10, 04 and 22. So how can we read our input file in our main program, so we don't have to read from like standard in to prompt the user for input or anything like that. So how we do that in Fortran is we open a file. I'm just going to declare some stuff first. So I'm going to kind of use, this is an intrinsic subroutine to get the current working directory. This is how you kind of consume it. So opening a file in Fortran, open keyword, you give it an identifier. So this could be the number 1, it could be 1, 2, 3, whatever. From memory, convention is to use a 3-digit number because I think some specific like single-digit integers are like reserved, like maybe the number 6 or 3, or there are some reserved, and I think everything kind of above 100 is free. So the convention I always used was to just start at 100 and then go up every time you open a file. The file path is the working directory, and then we put it in input values.txt. Nope, I did not. So new directory, let's put it in input, and move this here, factor, and rename this values. Cool. And status old. We can add the action as well. So action equals read, status equals old. I think that status old prevents it from creating a new file if one doesn't exist. So by default, it will always, I guess if the file doesn't exist, it will create one. An action read, I'm pretty sure will stop it from being written to. So we open the file. Then I'm going to notice in this text file we have a couple of like comments at the top. So we're just going to do 2 blank read statements on this file. So this identifier here, you're used to seeing so far read like this. So this is standard in. So now we're saying read from 100, which is what we opened. And we're just going to not do anything with that, right? And the next thing we're going to do is just loop, just do a loop. So do I equals 1 to, what do we got, 4 entries there. And let's just do something like, let's just read it and then write it out. So SN. SN. We got there. So I need to declare I here. Cool. So let's see if we can actually build this. Cool. So if we are on build, what do we call it? Example function. Yeah, so 10.5 0.22. Yeah, cool. So that's working there. 2.5 is the bottom. Yep. 0.0. Yeah, so there's some rounding issues, obviously, based on the precision we set here over real 4. What if we set these to real 8? Let's see what that looks like. That's going to give us a type mismatch. Never mind. So we've got those. We're reading in. We can write them out. So let's just basically delete this and move this whole code block from our program in here. So we're going to loop for the number of entries. We're going to read the row. We're going to perform the calculations, and we're just going to write to standard out here. Writing to a file is basically the same thing. You like could do 121 and give it a file name or whatever, but we're just going to print to standard out. Still build. and it's calculated the flow in each case. We've called the function. That's the end of it. So what have we covered so far? We've covered how to import a function from somewhere else to organize our code a bit better, have more composable code, reuse specific libraries, read from the file system, using modules. Yeah, it's pretty straightforward. If, for example, we'll do this in another video, I'm getting pretty keen to start some proper linear algebra in Fortran with matrices and stuff, but we could, in theory, define a matrix like this. 1, 2, 3, 4 by 4 matrix. And I'm pretty sure we could actually just do, let's say M. Let's just say right matrix M. That. Oops. We don't need this loop. Alright. So if we wanted to read the entire matrix, that's obviously not. Yeah, there we go. Let's actually do this just for formatting. So let's build that, run it. So we've got a matrix, and we see here it's just read the entire matrix in one pass, stored it in this 4 by 4 matrix we declared here. So yeah, that's it. I think that's enough of the basics. We'll jump into actually starting to build interesting stuff next. And if we discover any more parts of Fortran as we go, then that's fine. We'll just address them as we come to them. But I think we've got enough now to start doing some more interesting things.